Welcome back. This is an Aleks training video on writing the concentration equilibrium expression for heterogeneous equilibrium. Heterogeneous means you've got different states. You've got solids and liquids and gases mixed up, and the concentration expression is only dealing with gases. So anytime you have solids or liquids, totally ignore them, act like they're not there. Everything else, you put a concentration with the products on top in brackets showing that it's the molarity raised to the coefficient of that you see in the balanced equation, all multiplied together, divided by all of the reactants raised to its coefficient on the bottom. But I only want you to include gases. If you have solids or liquids, act like they're not there. Okay, so they gave you an ugly one just so that you can practice, but I don't think it's hard, it's just long. Okay, so we're going to look first at the products. So these are the products, okay, and anything that's aqueous is fine, anything that's gas is fine. Do not include liquids or solids because they don't change. All right, so I've got aqueous, aqueous, aqueous. Everything on top here would be included. On the bottom, I ignore the solid iodine, just act like it's not there. I ignore the water, act like it's not there, and the chromium 3 ion you would include. All right, so let's do this. So the case C is going to be a fraction. It's going to give you the CR2O7 negative 2 in parentheses or in brackets because that's the molarity. I look for its coefficient. There is none, so I just keep going. I make it a product then of the I. It's fine. So I, the iodide ion, it's got a coefficient of 6. All right, so that becomes raised to the 6th power. And then I keep going. The next one is H+. It's aqueous, so I include it. It has a coefficient of 14, so I have to raise it to the 14th power. Okay, my products are done. I come to the reactants. I'm going to ignore this one, okay, because it's a solid. I'm going to ignore that one because it's a liquid. So that means I'm going to have chromium 3 plus ion, and then I look, and it's got a coefficient of 2, so it's raised to the 2nd power. And that's how you do that.